Okay. Alright, back at it again with another stream. Let's get some music started. Probably be a bit louder. Okay. So, what did we do yesterday? Implement crawling. That's right. Um. So, there's several things that could be done at the moment, um, which are useful and sort of interesting, and I had a tough time deciding what to do. I'm still not ready to dive into UI stuff, so that's a ways out. I need a clear head to think about it, and today I felt slightly ill, so I did not spend a lot of time on that stuff. I did spend some time working on Trial. I fixed a couple of bugs there related to uniform buffer layouts, and now the lighting stuff should work properly again with the intensity things that I noted being broken on previous streams, so that's fixed now. I also did a couple of minor things in Leaf, but nothing to write home about. So, of the three things that I thought about doing today, those were adding in replays, adding in a move to AI, meaning an AI that can navigate 2D space and sort of move an object from one place to another, meaning which is a bit difficult because it needs to consider, moving along the ground, jumping over gaps and stuff like that. And the last option I considered was automated tiling, which is something I've mentioned a bunch and has been on my to-do list for a long time. And I think I'm going to do that. So to give you an idea, let's fire up Asprite here. Create a new file. Okay, let's also show the pixel grid. Alrighty. So, what is automated tiling all about? Well, I'm gonna make a secondary layer here. Okay. Alright. The idea of automated tiling is that given we have some kind of description of a surface, maybe, maybe we have I'm not sure how to denote this here. Something like this, I guess. Let's just stay simple for now. Given this description of a surface or this description of a shape based on simply an outline of pixels, the job is to determine which things are which way. More specifically, we need to be able to fill the area with matching tiles. So that means, for instance, if we want to make, let's say, things that are denoting the top floor should be green, so the algorithm needs to figure out how to do this. Let's say side tiles are cyan and yellow, so we want, let's make this a bit like this, and bottom tiles will be red. There we go. So, and of course corner tiles are some kind of mix, I'll just make them gray for now, or black, I guess. Okay, so then from thenceforth forward, the algorithm also needs to determine not just what kind of tile the ones on the borders are, but also it needs to generate an implicit signed distance function, which is going to tell me how far from the edges something is. So a very simple approach would be something like this. Make that like that. And then a bit darker. darker. Oops. And a bit darker still. There we go. So, ideally, this sort of coloring, I guess, is what our algorithm was going to produce from just having this description. And using this coloring information, it can reference a tile sheet and automatically tile in things. So at the top, or for each of these colors, it'll have a certain number of permutations that it can choose from, which it'll place randomly, and that'll make the bulk of tiling work a lot easier because it'll just automate the most of the work. Of course, afterwards you can still go back and do some manual editing to make things look a bit better, but this should provide a very quick and efficient way of doing the primary tiling of a level. So that's what we need to do. Now, what I thought about doing was that, let's actually move this maybe. Let's do it like this, there we go. So what I thought about doing...
Got in a bend.
Guten Abend, hello. What I thought about doing is implement a sort of cellular automaton, or rather a filter, is what you will call it in graphical terms. Because I'm pretty sure you can write this as a 3x3 filter on almost anything. So the idea being that if you see something like this, you know it's an edge. This center part is an edge like that. Or if you see something like this, you know it's an edge like that. The only problem cases are, of course, if you have something like this or something like this. Here you don't necessarily know what's in or out. So either the up part could be the inside or the lower part could be the inside. Same for the left and right problem. So how you might solve this is, before you do anything at all, before you determine at all what is, you're going to try and figure out which parts are inside and which are outside of the shape. And for this, we can use our existing float fill algorithm. So if you click somewhere inside here, it can automatically color everything until the bounding region with some sort of pre-existing color, and we can make use of that to determine what's inside and out. So for instance, we could take a secondary color, green, I guess, and we could color everything green, which means it would transform these cases into something like this instead, in which case it's clear what the center pixel is going to be. And from there on, it's only a matter of finding a simple edge point, so one point where we have an edge, and then moving along that edge until we find no more non-colored parts. And for each edge part, we simply apply this filter to determine the output. Okay, I think this is workable. I'm not sure how smart it is. There could be better ways of doing it, but I'm not too concerned. Yeah. Of course, here we don't represent things like slopes, which are much easier to do because there's only one choice there at the moment. Or rather, each slope already corresponds to a certain tile to pick, so there's not really much to do there. Okay. So, let's have a look at implementing this. Alrighty. So we have our flood fill algorithm here, which is good. And fine. Okay. How are we gonna tackle this? I think first we need to make a copy of the entire chunk that we can operate on without having to worry about it. So we can do the flood fill in that and then work from there. So I think the first step is to factor out this flood fill thingy to be more general, I guess. Let's also create a new file for this. Let's say this is, let's just call it autofill. Take this here. Not there. What the fuck is happening? Okay. So we're gonna call this later, I guess. What do I need the Z for? Oh, for the update. Okay. That's fine, we don't need that part. Not right now, anyway. Where's the flip fill? There we go. Okay, so we don't need that. We don't need that. Don't need these. Okay. With height. That's fine. Where does it get to? Oh, it translates them to X and Y. Okay. There we go. So now should probably just load that in. Okay. There we go. Deleting unreachable code. Hmm? Oh. Why is this unreachable code? I don't know. What? That's a function, fill? Oh, right, yeah, it is. Never mind then. Oh, God. What am I gonna name this? Fine. Okay. Great. What are we gonna call it? Rest, I guess. Auto tile or something. So, in order to do this, we're gonna need the solids layer with the height, the x and the y, the xxx and the yyyy, and the tile layer, and the tile map. But I'll worry about that later. Okay. So, according to what we sketched up, we first need to flood fill the entire area. So we're going to create a copy of the array. What? Solids. Copy sec. And then we're going to use the flood fill. And we're going to fill it with I don't know, something like this. Okay, so now we're at this state over here, where we've some kind of structure and everything is flood filled in with another color. So next is, I guess, just traversing upwards until we reach an edge. So loop for could use this again. Let's do the loop until actually that's interesting. So we need to consider another case where say this square here is our actual image bounds. So if we have something like this where it doesn't have a fully enclosed form, we need to make sure to not go beyond everything, and also not treat those as edges. So what do we do about this? Well, suppose we're just gonna iteratively search all of the edges. So if we go on the top, then we're gonna search right and then bottom and then left. If we keep not finding it, so let's also do this in a second function. X, Y, find edge. Okay. How are we gonna do that? Yeah. Let's add a. Whoops, that's not how that works. Also, good evening to 3 Finn, Mint, and Pincers. Welcome to the stream. Okay. Alright, good. I think that should work out right. So it's gonna go up, and I'm gonna go right until it finds one, or if it doesn't find one in all of the directions, then there are no edges. Alright, so now that we have an edge thingy, we simply operate clockwise along the edge. And each time we apply our 3x3 filter. That should be swell. Okay. So fill edge. Stopping condition would have to be well, if there's either no way to go or if we're back at the starting position. So let's make these new X's and Y's. All right. So the filter edge function is going to tell us what type of edge thingy we have right now, so whether it's a left, right wall, what kind of corner, and so forth. And then based on that, we can select a tile to fill in. Okay. And also based on that, we can then advance the cursor and step to the next one. So I'm gonna name these very good names. It's a bit more difficult to Actually, this is a bad idea. Let's say just so left-facing wall, right, or top and bottom, and then we have a left top, right top, left bottom, or right bottom. These kinds of corners, and otherwise, what else do we have? Well, we have the we do have the slopes, which are basically just top tiles as well. I don't think they are any different. Yeah. Well, we also have inwards facing edges. So... Okay. Good. That's our cases. And for now, I'm just going to fill in what's needed in order to advance our step rather than anything else. So when we have a left-facing wall, we're going clockwise, then we have to increase our Y. If we're on the right, we have to decrease Y. If we're top, we need to increase X. If we're bottom, we need to decrease X. We're on an outwards facing corner in the top left, or left top. I should name these differently. There we go, top left. Then we need to increase X. Top right, decrease Y. Okay. We're in a top left inwards facing corner, which is... I'm not even sure if that should be this or this. I guess this is... What would sound more natural? Top left inwards facing corner. Is that this tile? Or this tile over here? What makes more sense? I honestly don't know. Could go either way, really. I think I'm gonna go with this one, since it's, I guess... No. I don't know. I'm gonna go with this one after all, because then it's still clockwise. This, and don't have an example of the other one. Okay, so in that case we need to increase Y. And then if we're there, we need to increase X. And if we're there, we need to decrease Y. Yeah. There we go. That should cover all the cases to actually traverse the edge alongside. Don't even need the pause thingy. Actually, okay. This still doesn't work unless we have a closed loop. So if there is an edge that's out of bounds, this doesn't handle it. I guess I could call find edge each time. if it's out of bounds. So never actually used multiple value set Q. How does that work again? Multiple value set Q. I think I can also use set F with a values form. Find edge. Yeah, that should work. Variable tiles is never defined. Yeah, that's fine for now. Oh, it's just a list of variables. Okay, fine. This is a lot more intuitive though, like this. This probably expands into multiple value set Q, right? No, it doesn't. Interesting. Okay. Alright, now we need the filter to determine whether we're on what. So with filters, filters are a very, very convenient thing. Or rather, you can express a lot of things through filters, but in order to make them easy to use, you typically do something called, I think it's called stuffing. I'm not quite sure if that's the correct term anymore. But essentially what you do in order to avoid bounding conditions, where since we have a 3x3 filter, if we're at the edge here, then we need to take special care. You simply expand the image by 1 or by the edge size of the filter, so that each axis is always going to be valid no matter what. And that's a very convenient way of doing things. I just don't know if I'm going to do that. Okay, anyway. But a lot of, you know, when you're doing filtering and you need to go fast, you typically do that because the memory hit is far less than the performance hit from having to constantly check. Okay, for now I'm going to write this assuming that we don't have edge boundary problems. Okay. So we need to look at the top, bottom, and left and right pixels and see whether those are filled or not. Or rather, with what they're filled. So let's see, up is gonna be, probably need a thing here. Okay. And now it's just a cons of matching up these cases. typically a filter, when it's applied, it also just computes some new value for the current pixel based on the surrounding area. We're not gonna quite do the same because we're not doing image-based stuff directly, but you could conceptually do this stuff on the GPU as well, of course. But yeah, we're just gonna do it like this in a more intuitive fashion, I guess. Okay, if we have both up and bottom. Actually, there's a lot more cases that I didn't consider in my previous examples down here. So let's actually make a list of all the possible cases. So yeah, of course, case of this. And then we have to, of course, case this. This. Let's go clockwise again. Wait, that's not right. Should be like this. It's also not right. Okay. Can I get a 3x3 thingy? Should make it a lot easier to see. Okay, there we go. Hooray! So we have these cases, and we have some of them, well, all of them twice for the respective inwards and outwards facing situation. Did the music just completely stop? What happened? No, there it is. Okay, good. So we have this case and this case and these cases. Whoops. Okay. But then we also have this case, or this case. Right. And then, yeah, you might have another case where you have no insides or outsides at all. It's just a thing. And then for these you might have different variants. So you might have this. Can't really have any fillings there, so this is unambiguous at least. But you could have it without filling, I suppose. And stuff. Okay. So these are all the possible cases we can encounter. And that's quite a lot more than I was initially anticipating. Because I didn't think about the case of single line borders. Or solids, I guess. You know. Something like this. Actually, in these single cases, it's also not clear where it should go from there, because there's no clear direction to walk in. Oh boy. I could just abandon those cases. That will make life a lot easier. Just leave it up to manual. Yeah, I think for now I'm gonna do that. Okay. Okay. Otherwise, things are going to get more complicated with having to remember state of whether you're currently going along this or against it again. And yeah, I mean, it's certainly doable, but I kind of don't want to think about it right now. Focus on the simple case first. Okay. So, if we have both the upper and the bottom part being a solid, that's not our temp fill color, then it is, well, a wall, and if the left facing part of that is our temp color, our insides color, then it's a right facing wall, and otherwise a left facing wall. And now we just need to repeat this case for the other parts as well. So that handles those cases. And now we need diagonals for these. Or do I? No, I don't. The left is filled. Then, say top left. Wait, hold on. So we're looking at this. If the bottom and right are...
You're doing a good job, buddy.
You don't even know what I'm doing, do you? You have no idea. Yeah, in this case, these are not even matched up. Yeah, maybe I should have renamed them after all. Yeah, I think I'm gonna do that actually. So...
That doesn't matter. You're still doing a good job.
Wait, so... Right, so I need to flip these. This needs to decrease y. I think that's correct. Okay. I don't know, man. It's just, you know, if you can't tell whether I'm doing a good job or not, it seems kind of... I don't know. So let's make this a bit louder. There we go. Okay. That's that case.
Find me outside, then.
So that should work. Time for a test case. Oh boy. Writing this down is gonna be a pain in the ass. Okay. Let's see what we can dig up. Okay. Auto tile. Width was 1, 2, 3, 4, 5, 6. And height was 1, 2, 3, 4, 5, 6, 8. And as X, we're gonna be 1, 0, 1, 2, 2, 2. Should be good. Auto tile. Alright, so what is it doing? 2, 5, 2, 6. Two. It starts here for some reason. And then it goes to 2, 6, 3, 6, 4, 6, 4, 5, 4, 4, 3, 4, 2, 3, 2, 3, 1. What? Hold on. Something isn't right. Oh, the image is flipped. Right. Where is it? Hold on, I'm confused. Yeah, it's currently going the opposite way. Because it's considering the image flipped. But hold on, so let's see, 4, 2. 4, 2. And then it goes 3, 2. Okay. 3, 1, yes. 2, 1, 1, 1. 1, 2, 1, 3, 1, 4, 2, 4. Okay, yeah, so it goes to the right. It circumnavigates the thing properly. Good. Goody. Let's also print out what kind of edge it has. 4. Okay, so at 2, 5 it sings 2, 5. It has a bottom right inwards facing edge. Interesting. And then wait, what? 0, 1, 2. Oh wait, here. Yeah. What? Oh wait, this is after the thing, after it moves, so this is... Yeah, this is correct. Okay, and then the left edge. So I should really be doing this before the case to make this accurate. This is the second time today where the problem was actually in how I was printing my data rather than the actual data itself. Okay, let's have another look. 2 and 4. 2, 4. Okay, that's inwards and then left. Good. And then a top left outwards. Yes. And then a top and a top right. Okay, yeah, so if the image is considered flipped, then yes, this works out wonderfully. Nice. So now we need a map that tells us which tiles to use for any kind of given edge. Okay. Okay. Let's start with that. So, I actually want to try this on a real sample soon. So, let's look at... hold on. What was our initial tile map thingy? There it was. Actually, let me just... I'm probably not going to reuse that, to be honest. Okay. Alright, let's implement that map. Edge map. So for top edge we had... oh my god, this is gonna be annoying to fill out. That's 0, 1, 2, 15 in Y and X is 1. Right would be then 2, 14. Bottom would be 1, 13. And left would be 0, 14. And then teal. So that will be still in the 13 range, but that will be 7. Top right would be this one. So that would be 6. Okay. So that should give us the tiles in this map, in this particular map. Actually, it's... alrighty. Okay, that should be all. For now. There's still a lot more to add, but let's do a brief test. Go flip fill and so that, what was it? Auto tile. Let's make this percent and then a chunk. Ah, fine. Whatever. So here we need very similar things. Okay, also move this back. Okay, that should be everything. Alright, so here's a sample thingy. Let's make a simple part. And go. Ooh, nice! Some tiles were misaddressed, but mostly there. Hey. Okay. So those are misaddressed. It's that, so we're offset by 1 in both directions. Did I miscount? It's weird. Well, let's just try this then. Not quite, no. So now, this was correct, I think. It's just the accent was offset. Why is this? I'm so terrible at this. This has to be a bottom right. And that's a... Where is that? It has to be a... Wait, what? I'm so confused. Ah, my god. Bottom left and top left. This is the top left. And the bottom left, right. Yeah. Of course. Okay, let me quickly change that. So we have all the corners. Okay, this one is not yet correct. And that's the bottom right corner. There we go. Okay. Nice. So let's do that again, just to show how it works. Switch to layer 3. Okay, I'm gonna draw whatever I want. And fill it in, and it crashes. Great. Oh, because of this. Okay. There we go, though. Get that settled. Works just fine. Nice. Nice, nice, nice. See? Now I can fill in and create things in absolutely no time.
Sorry I'm so late. I got distracted and forgot everything that needed doing. What are we working on today?
What I just showed you. Can do it again if you didn't see it.
Oh, autofill of shapes. That's really cool.
Yeah. Could work a bit better, but yeah, it's pretty sick. Alright. So we have the exterior mostly handled. I want to see how it reacts to corner cases though. So if I do something like this, or if I do something like this, or something like this. Okay. What? Okay. So, filter edge. Optimize the values out, that's no good. Because the X and the Y
That's
values
an
don't-
excellent error message.
Yeah, I know. That doesn't tell me where that is. Hmm. Wait, what? Why does that still error? That is weird. That shouldn't have been a problem at all. Okay, now it just is fucking with me. What is this? Why is it suddenly not work? Oh. Because I was drawing on the wrong thing. Fucking hell. That's why I was never drawing any solids at all. Good going, me. Okay, let's see. Okay. Kind of. I think the edge cases should come before these cases. That should be a bit more
Really
stable.
should have something that shows what layer you're on.
Yeah, I know. I'm waiting for my UI toolkit. Okay, and that crashed it. Interesting. Interesting. Why did that do the crashy thing? Yeah, I'm fine with it. Doing it as before. Just means I have to fix it up in some cases.
Though, could definitely handle that better. Well, before I focus on that though, I do want to get the internal filling proper as well. How are we gonna do that? Well, well, if we go back to this, the problem now is getting this pink stuff here, meaning that the farther we are from the edge, the more pinkish it becomes. The first idea I have is to use something that tries to go along the existing edge, sort of, you know, like I was doing here, an onion skinning kind of thingy. There is of course also the possibility of creating a implicit signed distance function using moving least squares, but I forgot how to do that, and I would rather not deal with that stuff because it's just matrix heavy and yeah. Well, actually moving least squares wouldn't even work for this. It would just be a global optimization since we don't have enough points. Or we kind of do. Whatever. Anyway. Hello, Willie. Good evening. Welcome to the stream. So we could do a similar thing as before for the innards. I'm working on auto tiling, meaning that I can draw up some kind of shape with the solids. So I define a surface like this, and then I fill it in, and it does the magic automatically of knowing which tiles to put where. It's interesting that I ignored these entirely. Oh, because it detected this as a thing. My game is... Well, currently it's not about much, because it's still in the very early phases. But at some point, it's supposed to become a post-apocalyptic detective adventure platformer game, if you just want the buzzwords for it. Okay. Right, so I think the innards, the onion skinning can be done with another filter, a similar one, but this time instead of... Can it be? Yeah, I think so, but this time instead of looking at the center, we mostly look at the outer pixels. What program is what? The text editor or what? That's Emacs. Text editor is Emacs. The engine is custom. I'm really wondering whether there's a simpler approach than what I'm currently thinking about. Also can probably easily improve current thing. Fuck. Or can I? So this should now. Strange. Why is it saying unknown configuration? So it's this case I'm currently considering because it should put it into an inwards facing edge. Maybe it's failing somewhere else. I can't really know because I don't know what these positions are. Also, this week is going to be another really hot week. That is going to turn my room into a boiling kettle, and I can already feel it. It's been pretty hot the past few days already. Let me just add a improved Chromium. Alright, I don't have a whole lot of time left, half an hour, so maybe I can get the onion skinning done in that time, but I'm not sure. Okay, so...
Hop in a cauldron and throw some herbs in, soupy boy.
No thank you. So... It's actually... Yeah, I'm also seeing problems now if you have something like this. Or rather, you know, something like this. Great. If you have something like this, and it starts out here, right, and it goes like this, and then here it doesn't know what to do, it can't move up or down. It needs a memory, it needs some kind of memory to know where it came from before in order to resolve cases like this, which is annoying. I really wonder if there's not an easier way of doing that. Of doing all of this. If we had the information, knowing where we came from before, then we would have to check along the same edge if there's still something, and in the direction of where we came from. And in that case, I think with only that we can determine where to go. Not sure if that applies to all the cases though. So we're here. We stepped up before. So now we check in front, there's nothing. And we check to the left because we came up and there's nothing. So we go left. Previously we went left. We check below. And in front there's nothing, and we still have there, so let's go.
Any particular reason you don't want to pass the previous and starting locations to remember?
Because I assumed it was going to complicate the algorithm. Having to keep more state is typically more complicated than not. But in any way... Alright, so let's consider this. If we're going up, we have to check to the left. And if there is nothing to the left, we have to go left next. Or rather, if there is something. There is something to the left, we continue upwards, so we have the left case. Otherwise, no wait, if there is something there. Go right, so we have the, let's just say, okay. So if we were going to the right, then I need to check whether we're still above ground. And if we are, and if there's nothing in front, or if there is something in front, then we go down. If there is nothing, we proceed right, and otherwise we go left. Actually, instead of px and py, I can do a prev. Okay. People are going down. That can't be right. We're going right, and there is nothing. Then we need to go up. Okay, I think that's correct. Okay. Someone asks on IRC or Twitch how I'm doing. It's doing alright. Made some progress. Some part of it is implemented, but having a bit of trouble getting the entirety of it done. Okay. Should be a similar thing to this, to be honest. Okay. If we have a left-facing edge, then we need to decrease x by 1. in order to get out of there, and we have, I guess, an upwards motion before. If we have a right, then we need to... No, wait, if we have a left, we need to increase. Right. And down, I guess. Top, then we need to... We have a top left corner, then we need to decrease both X and Y. And we need to go to the right. We have a top right corner. No, we need to increase X and decrease Y. And I need to go down. The bottom right. Decrease X, increase Y. I need to go to the left. Okay, and inwards facing corners. Wait, hold on. Yeah. You can just move one to the side. So that will be that, so we can increase Y and say we were going to the left. We have, can just roll these in with these actually. Right. Have it right, then we're also gonna... Okay, I think that should be correct. ZF tile, what do we have here? Let me just pick one, so this is actually... Where's the edge map? 114. Okay. Let's give her a shot. Here goes nothing. Hey, it worked. Nice. Hey, don't you love it when things just work? Nice, nice. It's only one layer though.
Mission
and
complete.
the other layers are going to be much more annoying, I feel like. Huh. Okay, well, I'm out of time, but we're making good progress here. So now I can just draw something up and let it crash. Am I on the right tile even? I don't think I am. Yeah, I'm not. God damn it. Switch to the right thing, asshole. Where is it? There it is. Okay. Draw something up and crash. Because of that. There we go. That's better. Okay. We're getting there. It also still only does like one kind of tile. Obviously, I want to have a list of possible tile kinds and which it can pick randomly from to make it a bit more alternated, but that's an easy fix. The layering is going to be a bit more of a tough one to crack. I think what I'm going to have to do is like modify the current layer to also add solids there, and then from the last one we filled, try to push outwards until we find an inwards thingy or something. I'm not sure. I could see a lot of situations where you might get like stuck, so I don't know. I'll have to think about it. But for now, let me add that file. So this can be something here. Autofill. Did I change here? Right. Start work on auto-filling tile maps. Okay. Naturally, once we have a UI toolkit, I would also like a UI to like easily designate which tile is what kind of thing. And all sorts of things, but that's still a ways off. Still thinking about UI toolkits and all of those things, but today was a bad day for that, because I was feeling pretty sick, and I didn't bother thinking. Okay, anyway, thanks again to everyone, as always. Thanks for stopping by, and have a good night. See you tomorrow.